Okay, as you can see, I have a set of numbers from 1 to 40. Okay. Hi everyone, Ali here. And I am gonna circle some numbers. Let's see. Okay, 2 is good, 3, 5, 7, and then 11, 14, 17, 19. Okay, I guess you know what's going on. And then this one, and this one. Nice numbers. Okay, and finally this one. So I guess it's obvious all the prime numbers less than 40. Actually, yeah, that's all. Okay. Now there is a question. Can I write a prime number p obviously stands for prime, as sum of two squares, like a square plus b square equals p? Actually, this is a question. P is prime, a and b whole numbers. Is it possible or not? Okay, so let's see. For example, 2. 2 is the first prime number. So can I write 2 as sum of two squares? Obviously, that's possible. 1 square plus 1 square. And then what about, just about 2. 2 is, as you know, the only even prime number. So, you know, I guess 2 is a weirdo when we are talking about prime numbers. So, let's forget about this one. And maybe just talk about odd prime numbers. You know, all prime numbers are odd except 2. So, let's forget about this one. I'm gonna check, although it was possible to write it as sum of two squares. Let's talk about this one. Is it possible? It's not possible. For example, if you have 1 square plus 2 square, that will be 5. So, not possible. Actually, we just saw 5 was possible. 1 square plus 2 square was about 7. If you think about it, you can easily realize that it's not possible. What about 11? Not possible. 13 possible. We can write it as 3 square plus 2 square. 9 plus 4, 13. This one is possible. It's 4 square plus 1 square. This one is not possible. This one not possible. And okay, 29. Actually, this is possible. Let's see, maybe 5 square. Yes, 5 square and 2 square. 25 and 4, 29. This one not, and this one is possible. Okay, our final prime number less than 40. Let's see, maybe, yes, easy. 6 square plus 1 square. Okay, so these are all the prime numbers less than 40. What if we have a very large prime number? So how can we realize if we can write it as a square plus b square or not? I mean, what is the way to understand it? Actually, there is a really easy way, and it's really cool. Okay, let me change the color, maybe pink. Okay, I have a pink chalk. For example, you want to check, okay, our first number. Oh, this was 2. Let me write it down. Okay, for example, you want to check 17. We know it is possible to write 17 as sum of 2 squares. But there is another easy way to understand it. So let's check the number behind 17. Like 17 minus 1 will be 16. Okay, it's all about this number. If this number is a multiple of 4, we can write this prime number as a sum of 2 squares. Is 16 a multiple of 4? Of course. This is 4 times 4. So 16 has the form 4k. And because this, we can write 16 as 4k, 17 can be written as sum of 2 squares. Looks weird, but that is correct for all odd prime numbers. Actually, for all prime numbers except 2. And as you know, there are infinitely many prime numbers. Let's check one more. 37. Okay, so we wanna check this number. Is it a multiple of 4? Yes. Actually, this is 9 times 4. So it has the form 4k. We can write it as 37. We can write it as 6 squared plus 1 squared. So let's check one of these. For example, 23. We cannot write it as sum of 2 squares. Maybe you can pause the video and try. You can see there is no way to write 23 as sum of 2 squares, like a squared plus b squared, where a and b are whole numbers. Okay, again, same strategy. Let's check this number here. Is it a multiple of 4? Actually, if you divide 22 by 4, you have 5 times 4, 20, and then there will be a remainder. So, I'm using my hands barely. So, because this is not a multiple of 4, we cannot write this prime number as sum of 2 squares. I guess this is a really cool theorem, which is called Fermat theorem. So let's recap. As a recap, if P is prime, P can be written as sum of 2 squares, a squared plus b squared, if and only if, if it double F means if and only if. Another notation is this one. P has the form. Okay, let's think about it. I said the number behind your prime, if that number is a multiple of 4, you can do it. So if you add 1 to a multiple of 4, 4k plus 1. So if your number has a 4k plus 1, you can write it as a squared plus b squared. Lovely theorem. That's all for this video. I hope you enjoyed it. Take care.